Welcome to another exciting episode of the Organic Chemistry course. So, today in this episode, we are covering carboxylic acids and their derivatives. So, in the first subheading, we are trying to look at how carboxylic acids are formed. So, carboxylic acids are formed from the oxidation of primary alcohols. So our primary alcohol is oxidized by acidified potassium dichromate 6 or acidified potassium manganate 7. I call your attention to two of the previous videos that I've covered, those being hydroxy compounds and carbonyl compounds. I covered this theme in very great detail. Okay, so when a primary alcohol is heated in the presence of a weak oxidizing agent such as acidified potassium manganate, it produces your what? An aldehyde, right? And from your and further oxidation produces a what? A carboxylic acid. But if a strong oxidizing agent is used, such as acidified potassium manganate, the reaction takes place immediately from the alcohol directly to a carboxylic acid. That's all there is to it. Okay? Carboxylic acids are also formed from the oxidation of aldehydes using the same oxidizing agents, acidified potassium dichromate 6 or acidified potassium manganate. From your aldehyde to produce your carboxylic acid. So carboxylic acids are also formed in the third reaction. Carboxylic acids are also formed from nitriles. Nitriles are hydrolyzed in the presence of an acid to form a carboxylic acid and an ammonium ion. So, I call your attention to the video under halogen derivatives, whereby we had our halogenoalkane, right? Where we replaced the halogen atom with a cyanide group of atoms. So this compound that is formed, we said it results in an increase of carbon atoms in a chain. This nitrile, when you add a dilute acid, it forms a carboxylic acid plus an ammonium ion, right? If the nitriles are hydrolyzed by boiling them with sodium hydroxide, right, the product would be ammonia and a salt. Like in this case, we have ammonia and a carboxylate what? Salt. So the salt can be converted back into a carboxylic acid, right? By the addition of HCl or sulfuric acid. That's all there is to it. Okay? Let's move on to another subheading whereby we're dealing with reactions that have to do with carboxylic acids. Carboxylic acids being acids, right? Carboxylic acids being acids react with bases such as sodium hydroxide to produce a salt and water, right? The next reaction in which they participate is that carboxylic acids react with metals to liberate a salt and hydrogen gas. This is a typical example. Our carboxylic acid here plus our metal, resulting in the formation of our salt plus our hydrogen gas. I don't think there's anything new here. Now here is a takeaway, and nice to know. Carboxylic acids being acids, they react with the base carbonates to produce a salt, carbon dioxide, and water. You may also make a contrast with phenol. This is where carboxylic acids tend to be stronger than phenol, but phenol is not able to liberate carbon dioxide from carbonates. Carboxylic acids are stronger than what? Than phenol. Okay? Now, in our new subheading here, there's supposed to be oxygen there. Okay, there's supposed to be an oxygen there. Okay? So, I want to talk about esterification. Esterification, this is a type of reaction that takes place when carboxylic acids, right, in this instance, reacts with alcohols in the presence of trace mineral acids, chief of which is sulfuric acid. Right? To produce our ester and water. Right? Acyl chloride formation. So carboxylic acids react with PCl5, PCl3 and SOCO2 to form an acyl chloride. This reaction, I'm sure you saw these reagents when you're doing hydroxy compounds. They react in much the same way. Okay? Let me take you to the page where these reactions were taking place under hydroxy compounds. Okay? I believe it's this page, yes. These reactions that I have here. These substitution reactions. You had your OH group here being replaced by a halogen atom over there. Okay? This OH group being replaced by a halogen atom over there. And this OH being replaced by what? A halogen atom over there. It is the same when we're now talking about what? Carboxylic acids. Okay? This OH being replaced by chlorine. This OH being replaced by a chlorine. And this OH being replaced by a chlorine. The coefficients in for the molecules in the alcohols and the carboxylic acids are identical in every way and in every sense. Okay, so I advise you guys to look at those two reactions and try to create a contrast that may help you to remember. Okay, so the acidity of acyl chlorides is the new subheading that we want to talk about. Carboxylic acids are weak acids. They partially dissociate in water to produce a carboxylate ion and a proton. Let me talk about this species here. Let me just call it an R. Or in R, let me just call it a group that is attached to the what? To the COOH group. Okay? If this R causes this COOH group to be electron deficient, that makes the acid stronger. If the R group makes the COOH group electron rich, it makes the acid weaker. In other words, when we say an acid is weak, it is not susceptible to losing a proton easily. Okay, let me move on in the bottom there. I don't think this is important. Okay, don't worry about this. If I find it necessary, I will do a separate video on this. I don't think it's important. Okay, let me just remove it from your side. It may just offset your attention. Now, I have 4 molecules there. And what I was intending to do was to compare their relative acidities. Okay? I was trying to compare the relative acidities of those 4 molecules. So we have our acyl chloride. We have our acyl chloride over here, which I said in the introductory topics to say acyl chlorides are one of the most, if not the most reactive organic compounds, right? They are one of the most reactive organic compounds. So they are the most acidic in this instance because they are hydrolyzed by water at room temperature without a catalyst to produce a completely dissociating HCl. Right? I've said that statement in these lectures more than once. Okay? Now, let's go back to the theme that I was trying to explain. We've got B being the second most acidic and C being the third most acidic. Why? Because the chlorine atom there is very electronegative. This one is 2 chlorine atoms which withdraw electrons from the what? From the COOH group, making it electron deficient. If the COOH group is electron deficient, that makes the acid stronger. It makes it susceptible to losing a what? A proton. Now this one has got 2 electronegative species. That's why it's number 2. This one is number 3 because it is only 1 electronegative species to withdraw electrons from the COOH what? Functional group. Now this one now does not have an electronegative species to withdraw electrons from the what? From the COOH functional group. So what happens? Alkyl group tends to push electrons towards the COOH group, making it electron rich. Therefore, it does not easily lose a proton. Okay, that's what I was just trying to say in these notes. Okay, here I said for D is the least acidic. D is the least acidic because it does not have any electronegative species that pulls electrons away from it. That's all. Hydrolysis of acyl chlorides. As you can see, we have our acyl chloride. We have our acyl chloride over here being hydrolyzed at room temperature to produce our carboxylic acid and our HCl. Right? These reactions take place at room temperature and lead to the formation of the completely dissociating HCl. Okay? The mechanism here also is what is also, I don't think it's necessary at this point in time. Let me just remove it. Okay, it's not necessary at the moment. We don't need it at the moment. Okay, let's move on to the next subheading there. Reactions of acyl chlorides with alcohols. Acyl chlorides react with alcohols, right, to produce an ester. Dense white fumes of HCl are also what? Produced in the sweet smell. Okay, acyl chlorides react with alcohols to undergo an esterification reaction. In this reaction, because we have an acyl chloride here, no acid catalyst is required. No acid catalyst is required. Now with phenols, acyl chlorides now react with phenols. Acyl chlorides react with phenols to undergo an esterification reaction, and HCl is produced, right? So we have our acyl chloride here reacting with phenol to produce our ester and HCl. We have our phenol here and our acyl chloride here to produce our ester and HCl. So during these reactions, these esterification reactions involving acyl chlorides, phenol must be dissolved in sodium hydroxide or pyridine. This is just a nice to know statement, okay? A nice to know statement. Acyl chlorides also react with primary amines to give amides, okay? So this is the reaction. In this reaction also you have this HCl being produced, right? This HCl being produced. Okay. Next type of reaction is the formation of esters from acyl chlorides. We've said this before. These are type of esterification reactions. Okay. Here you've got your acyl chloride. You've got your acyl chloride reacting with ethanol to produce our ester there and HCl. Here you've got ethanoic acid reacting with ethanol to undergo an esterification reaction, right? To produce your what? Your ester and water. Here you've got your acyl chloride reacting with phenol to produce another ester here, okay? Plus HCl. And the next one, also you have this type of acyl chloride, okay? Reacting with phenol, produce an ester here plus HCl. They're just examples of esterification reactions, okay? And I also wrote a nice to know statement at the bottom there to say esters have a sweet smell. Flowers are scented due to the presence of esters which are produced from alcohols by the anaerobic fermentation, right? This is just a nice to know statement, okay? Nice to know statement. This page, I believe, is reproduced here. It's here. I reproduced the page here so that way so that it becomes more clear, okay? So, acid and base hydrolysis of esters. Hydrolysis is just a combination of two words. hydrolysis. Hydro meaning water and lysis meaning I think it's a Latin word which means breaking. So acid-base hydrolysis of esters, we're trying to break down the ester into its constituents by adding an acid or base. So here we've got our ester there. By adding a base, which is sodium hydroxide, we produce our carboxylate salt and ethanol, right? The salt is converted into a carboxylic acid by the addition of what? HCl or sulfuric acid over here. Okay? If hydrolyzed in the presence of an acid, a carboxylic acid and an alcohol are the products. Okay? Yeah, and by heating this and under reflux conditions in the presence of an acid, right, you produce your carboxylic acid and your ethanol. Okay, so as we close this topic, I want to talk about the commercial uses of esters. Okay, so esters having a sweet smell are used in the perfumery to make perfumes. Okay, they are also used as solvents in paints. Right, and the third and last statement is that they are also used as artificial flavorings for food. Artificial flavorings for food. So this brings us to the end of this episode. I hope you found this video helpful, and if you did, please help support the channel by commenting, liking and subscribing, and I'll see you all next time. Thank you guys. Thank you and take care.